For the circuit shown below, find current I. This is the given circuit and here I is shown. We are supposed to calculate this I. So let me simplify this. So this problem can be solved either using loop analysis or using node analysis. So if we solve using node analysis, then we have this is one node, this is another node, and here this and this together we have one node. So this is one method to solve the problem. The another method is we can solve this using loop analysis. Let me solve using loop analysis. So by observing this circuit, we can see that here we have 1, 2, 3, 4. There are 4 loops. So if there are 4 loops, it is very tedious to simplify. I will try to convert this into 3 loops. So here we can see 1 volt voltage source is in series with 1 ohm resistor. So here I will apply source transformation and I will try to convert this voltage source into current source. So that is, this is the voltage source in series with the resistor. I will try to convert this into current source. That is, we know that I is equal to V by R. Here voltage is 1, resistor is 1. So the magnitude of current is 1 amp. So let me redraw the circuit where I will convert this 1 volt into current source, and in that case this resistor will appear in parallel. So let me draw the circuit. So here we have a current source. The magnitude of this is 1 amp. Because this end is positive, this is negative. On positive end we have to consider head end of the arrow. So this is head end of the arrow and this is tail end of the arrow. Similarly here this 1 ohm resistor will come in parallel. So to this 1 amp we have 1 ohm resistor which is in parallel now. Rest of the circuit I will draw as it is. Here we have one more 1 amp. I will connect it as it is. This is 1 amp. This is 1 amp I have connected as it is, and rest all the circuit I will connect as it is. So that is, here we have 1 ohm. Here one more resistor, that is 1 ohm. So here we have a voltage source and we have a resistor. This is 2 volt, this is 2 ohm. So here we have 1 ohm. Here we have 1 ohm. So this is I. So now in this circuit we can see 1 amp and 1 amp current source are in parallel. Both are in same direction. We can replace these two current source by single current source. That is, I can replace these two current source by 2 amp. That is, both will be added up. This is 2 amp and this 1 ohm will appear as it is in parallel. So this is 1 ohm. Rest of the circuit I will draw as it is. So this is 1 ohm and here we have 1 ohm. This will be connected as it is. This is minus plus. We have 2 ohm. This is 2 volt and here we have 1 ohm resistor and here we have 1 ohm resistor. This is 1 ohm. So now I will convert this current source which is in parallel with a resistor into voltage source. That is, we know that V is equal to I into R. That is, I is 2 and resistor value is 1. So magnitude of voltage source is 2 volt. And this resistor will appear in series with this 2 volt voltage source. So here I can redraw the circuit where this is 2 volt and here we have 1 ohm resistor will come in series. Rest of the circuits I will draw as it is. That is, this is 1 ohm and here this is 1 ohm. So now here we have 2 volt voltage source. This is 2 ohm and here we have 1 ohm. This is 1 ohm. So now here we can see that we have 3 loops. Now let me simplify this using loop analysis. So as we know, in loop analysis, first we have to mark the loop currents. Let me assume this is positive terminal, this is negative. Let me assume current through this loop is X. Take the current direction from positive to negative. Here there is a voltage source. Take the current direction from positive to negative. I will take in this direction. Let current in this loop is Y, and let current in this loop is Z. So now let me apply KVL to each loop. Let me apply KVL to loop X, that is apply Kirchhoff's voltage law to loop X. So now we are supposed to apply KVL to this loop. So start from the voltage source, keep voltage source on left hand side, that is 2 is equal to, now move along with the direction of current. Voltage across this is 1 into X, that is 1X, that is nothing but X, 1X plus, we have voltage across this 1 ohm resistor is X, 1 into X plus Y, because X and Y are flowing in 1 ohm resistor, both are in same direction. So it will be 1 into X plus Y plus, then the current will flow through this 1 ohm resistor where current X and Z are flowing. Z is opposite to X. So we should write it as 1 into X minus Z, because Z is opposite to X. Let me simplify this. 2 is equal to, here we have 1X, this 1X plus 1X, that is 3X. We have 1Y, that is nothing but Y, and here we have minus Z. Let me call it as equation 1. So now similarly apply KVL to loop X, loop Y, that is apply KVL to loop Y. So this is the loop Y. Start from the voltage source, keep voltage source on left hand side, that is 2 is equal to, now move along with the direction of current. First current will flow in 2 ohm resistor. So in 2 ohm resistor, Y and Z are flowing, both are in same direction. So it will be 2 in bracket Y plus Z plus, then current Y flows through 1 ohm resistor. So that will be 1Y plus, then current Y flows in 1 ohm resistor, but in 1 ohm resistor current X is also flowing. So we should consider X plus Y, that is 1 into X plus Y. Let me simplify, that is 2 is equal to, so here we have 1X, 2Y plus 3Y plus 1Y, that is 4Y, plus we have 2Z, that is 2Z. Let me call it as equation 2. So now apply KVL to last loop, that is Z, that is apply KVL to loop Z. So here let me apply KVL, that is 2 is equal to, we have 2 is equal to, voltage across 2 ohm resistor is 2 into Y plus Z, Y plus Z plus, now we have voltage across this 1 ohm is 1 into Z, that is 1 into Z plus, voltage across this ohm resistor is Z and X, but both are opposite to each other. Now we have to consider 1 in bracket Z minus X, because X is opposite to Z, that is 1 Z minus X. Let me simplify. This is 2Y plus 2Z plus 1Z plus 1Z minus 1X, or I can write 2 is equal to, we have minus 1X, we have plus 2Y, and that is plus 4Z. Let me call it as equation 3. So now we are supposed to solve equation 1, 2 and 3, that is solving equations 1, 2 and 3. So this equation 1, 2, 3 can be solved using Kramer's rule manually, or we can use the calculator. So to use calculator, keep calculator in equation mode, and here we have 3 unknowns, choose 3 unknowns and directly feed the values. So by using calculator we will get the unknown values as, that is X is equal to, it will be 1, and we have Y is equal to minus 0.1667, and we have Z is equal to 0.8333. So we found all 3 loop currents, that is X, Y, Z. Now we'll find I. So here we can observe that, so here current I, so we can see that I is nothing but y plus z. So current I is nothing but y plus z. Both current I is flowing in 2 ohm resistor. So in 2 ohm resistor, both y and z are flowing in same direction. So I can be y plus z. So we can say I is equal to y plus z, which is equal to y is minus 0.1667 plus z is 0.8333. So solving this, we'll get I is equal to 0.667 amps. So this is the solution for the given circuit. Now let me solve the same problem using node analysis. That is, I will calculate I using node analysis. So here we can observe that this node and this node all are same, that is all are shorted. Let me consider this as node V1. So here we can find another node. Let me call this as node V2 and this is node V3. So let me assume current through this branch is say I1 and let current through this branch is I2, and here we have let current through this branch is I3. So anyhow current I is flowing in this branch. Let me call current through this branch is I4 and current through this branch is I5. Now we supposed to apply KCL to each node, that is apply Kirchhoff's current law to node V1. So here we can see that Kirchhoff's current law means incoming current is equal to outgoing current. So in node V1, current I1 is incoming, current 1 amp is incoming, I2 is outgoing current and I4 is outgoing current. So I can write incoming current I1 plus 1 is equal to outgoing current, that is I2 plus I4, or I can write I1 is nothing but 1 minus V1 divided by 1. I1 is nothing but 1 minus V1 divided by 1. That is potential difference between this voltage and this node voltage divided by resistor, because I is equal to V by R. So this is plus 1 as it is. I2 is the current which is flowing from V1 towards V2. So IT can be expressed in terms of voltage as V1 minus V2 divided by 1, plus similarly I4 is the potential difference between V1 and V3 divided by 1, that is V1 minus V3 divided by 1. So let me simplify, that is 1 by 1 is 1 minus V1 plus 1 is equal to, here we have V1 minus V2 plus V1 minus V3. So let me simplify further. This is 1 plus 1 is 2 is equal to this V1 plus V1. So if we take this V1 on other side, it will be 3V1 minus V2 minus V3. Let me call it as equation 1. So now similarly apply KCL to node V2. So now apply Kirchhoff's current law to node V2. So in node V2, current I2 is incoming, current I3 is leaving and current I is leaving. So let me write I2 is equal to I plus I3, that is I2 is equal to I plus I3, because I3 is incoming current, I3 is leaving and I is leaving. So let me express I2 in terms of voltage, that is V1 minus V2 divided by 1. So I2 is nothing but V1 minus V2 divided by 1 plus this I is nothing but V2 minus V3 minus of minus 2 divided by 2, that is V2 minus V3 minus of minus 2 divided by 2 plus I3 is nothing but, so here I3 is the current which is flowing, this by default this will be 0 potential node, so I3 is V2 divided by 1 So we have V2 divided by 1. Let me simplify. V1 minus V2 is equal to, we have V2 by 2, V2 by 2 minus V3 by 2 plus 2 by 2, 2 by 2 plus V2. So let me simplify further. V1 minus V2 is equal to, we have V2 by 2 minus V3 by 2 plus 1 plus V2, or I can write it as V1 minus V2, I'll take V2 on other side, minus V2 by 2 plus V3 by 2 and minus V2 is equal to 1, or I can write V1 minus V2, 1 plus 1 by 2, coefficient of V2 is 1 by 2, and we have plus 1 plus V3 by 2 is equal to 1, or this is nothing but 1 plus 1 is 2, 2 plus half, that is 2.5, that is V1 minus 2.5 V2 plus this is nothing but 0.5 V3 is equal to 1. Let me call it as equation 2. So now similarly apply KCL to node V3. Let me write here. Apply KCL to node V3. So here in node V3, current I is incoming, I4 is incoming, I5 is outgoing. That is I plus I4 is equal to I5. I plus I4 is equal to I5. So current I is nothing but this one, that is V2 minus V3 plus minus of minus 2 is plus 2 divided by 2 plus I4. So here I4 is nothing but V1 minus V3 divided by 1. That is V1 minus V3 divided by 1 is equal to I5. I5 is nothing but V3 divided by 1. That is nothing but V3 divided by 1. Or I can write V2 by 2 minus V3 by 2 plus 2 by 2 is 1 plus V1 minus V3 is equal to V3. I can write it as V1 plus this is V2 by 2 minus V3 by 2 and this is minus V3. I'll take this V3 on this side, this will be minus V3 is equal to, I'll take this 1 on other side, it will be minus 1, or I can write V1 plus 1 by 2, V2 is nothing but 0.5 V2. So here we have minus 1, 1 by 2, that is nothing but 2.5 V3, that is minus 2.5 V3 is equal to minus 1. Let me call it as equation 3. So now solving equation 1, 2, 3 using calculator. Keep calculator in equation mode and choose 3 unknowns and directly feed the values. So we will get, that is solving equation 1, 2 and 3. So I will solve this using calculator. So we will get V1 is equal to 1 volts, V2 will be equal to 0.1667 volt and V3 is equal to 0.8333 volts. So now we have to find I. So we know that I is nothing but V2 minus V3 plus 2 divided by 2. So here we know I is equal to V2 minus V3 plus 2 divided by 2. That is I is equal to V2 minus V3 plus 2 divided by 2. That is V2 value is 0.1667 minus V3 is 0.8333 plus 2 divided by 2. So solving this will get I is equal to 0.667 amps. So here we can observe that the result obtained from node analysis is 0.667 amps, and whereas the result obtained using loop analysis is 0.667 amps. Thank you for watching.